我准备的那个 PPT 是用英文的，所以我想我还是用英文快介绍一下我们公司的背景，好吧？CloudMinds，我叫 Robert Zhang， 我是那个 CloudMinds 的 co-founder 和 US Office 这边的 CEO。CloudMinds, we're a 2-year-old startup, and our tagline is that we make robots smarter. So in the next about 10 minutes, I'll talk about how we are planning on doing that. A very quick snapshot about the company. We're founded in April 2015, and we have about 350 people right now. We have offices in the Valley here, and we also have offices in China, in Japan. And as I said, our value proposition is that we want to make robots smarter, make them more intelligent by being a cloud robot operator. So I'll talk a little bit more about what that means. And we're very fortunate in the sense that we have very strong financial backers. And also another big vision we have is that by 2025, we want to make it possible that every family will have a service nanny robot that will help you do household chores. I think that's a very ambitious goal, and I'm sure everybody here would love to have a service robot nanny that help you with your everyday household chores. So let's move on to the next slide. In our view, in the future, every robot will be a cloud robot. So this chart basically shows what that means exactly. So if you look at it, there's a robot. We all understand that you need a robot deployed either in your family or in your factory, wherever your use case may be. But the difference is then we also believe there is a need of deploying artificial intelligence in the cloud, which means that in order for a robot to be able to perform a lot of the challenging tasks in an unstructured environment, the intelligence is not sufficient, just only come from the devices or the robots itself. Therefore, you see the cloud, the brain. In order to make the AI capabilities to effectively communicate with the robots, you also need to have a secure, a secure and fast cloud. So basically, you have the cloud brain that we call HARRY, that's human augmented robot intelligence, where human intelligence is combined with machine intelligence. And then you have this global network that is optimized and secured. And then lastly, you have the robot, and also a connector that actually connects the cloud with the robot. So that's the big picture here. So let me talk a little bit about how we're accomplishing this. So I talk about the human augmented robot intelligence, HARRY, right? So this chart shows the progress that we're currently making in regard to the global network. So you see there's a HARRY data center and HARRY POPs, that's a point of presence, deployed all over the globe. And the approach we're taking is, I mentioned this yesterday in the panel, we're taking a telecommunications approach to robotics. That is, we're building these switches and also the distributed cloud brains all over the globe. And by having this cloud brain and network infrastructure, we'll be able to help make robots smarter. So basically, by 2020, we'll be deploying 10 HARRY centers globally. And by doing that, we'll be able to make the communication latency anywhere in the world about 150 milliseconds. So imagine with that kind of a low latency, a lot of robotic applications will become possible on a global scale. And then if you look at the lower right corner, I said 1 to 20. What that means is that by deploying these data centers and POPs, we'll be able to have one human operator managing 20 robots on average, meaning that in the cloud, we're not only deploying the AI capabilities, but also we have a scalable and flexible infrastructure where human operators will work in conjunction with the machine intelligence to help end users. So this is, I talked about the connection between the robots and the cloud and network. This is we call it data. It's really something we call RCU, meaning robot connection unit. Or control unit. So basically, you can do it in different form factors. The way that we're doing it right now is we're doing it in a mobile device form factor. So it has dual operating system, and it has dual modem, and also it can be customized from the hardware perspective. I'll basically explain why we feel it adds a lot of value to the robotics ecosystem in the next slide. So if you look at it, this data sandwich architecture, which is also a robot control unit, what it does is that you can customize the hardware so that when you have a robot, with the pre-designed capabilities, but if you want to easily add new features on the hardware side, instead of building another piece of hardware, you can use this robot control unit to extend the capabilities of that specific robot. So here are just a few examples of what this sandwich module could accomplish. Obviously, we need to work with our partners. We need to build out an ecosystem to accomplish this goal. If you want to turn the robot into a sort of a satellite communication tool or a robot, then you can just attach the module on the robot, and therefore quickly turning the robot into that specific device. To conclude, this is our view in the future. Basically, if you fast forward 10 years, you have all the different robots deployed all over the place, right? These are family robots, security robots, manufacturing robots, and so on and so forth. So our vision is that all these robots will be connected through the secured and optimized network that I described earlier. We call it virtual backbone network. And through 5G, right? And we know that 5G will be deployed starting from 2020. And then it will be connected to the cloud brain, right? That's the human augmented robotic intelligence cloud that we're building. On that cloud, there will be human intervention part of it. As you can see, there's the help desk, meaning that the human operator on the cloud will be able to leverage technologies such as augmented reality and virtual reality to basically work with the AI algorithms on the right-hand side. And the way that works is then the human component will enhance the AI, and AI will also basically help the human operator. So with that, we feel we can accomplish the ambitious goal that I said in the beginning of the presentation. That is, you can deploy a service nanny robot in different families, so that these robots, when they come across a task that they have not seen, they weren't trained before, they will be able to leverage the hairy cloud, and then therefore be able to accomplish those tasks easily. But again, to wrap things up, for this to happen, we really need to work with the robotics companies, at the bottom layer. We also need to work with the AI companies. Again, we are positioned as a cloud robot operator, so we want to work with the AI companies as well as the robot hardware companies. So if any of the guests here today are interested in talking to us about potential partnership, please come find me afterwards. With that, I want to thank you for your attention, and I'll also be moderating a panel later on about robotics. So I look forward to that. And again, thank you.